Hi, thanks for joining us today for this workshop on Kubernetes and OpenShift for developers. I'm Jan Kleinert. I lead the OpenShift developer advocacy team here at Red Hat, and this is what I looked like back when I used to get haircuts. Also with me today is Ryan Jarvinen, another member of the OpenShift developer advocacy team. Ryan and I will be available in the Q&A and the chat all throughout the workshop today if you have any questions or if you get stuck along the way. I'm going to move out of the way now so that we can look at the agenda. So we're going to start initially by making sure that you all get access to our environment where you'll have access to a cluster that you can use for the workshop. Then we'll have an intro to Kubernetes and OpenShift. We'll be spending a lot of time on fundamentals in this first section and working from the command line terminal. Then we'll move over to the OpenShift web console where you'll learn how to navigate as well as deploy applications there. We'll take a 5-minute break, and when we come back, we'll look at the ODO command line tool and do some iterative development using it. And then finally, we'll spend some time doing wrap-up, looking at resources, and understanding where to go if you want to take some next steps. And then we'll have some time for Q&A at the end. We'll also, as I mentioned, be available for Q&A or helping with any questions as the workshop progresses. Let's get started by getting everyone set up with our demo environment. If you're planning to actively follow along and do the activities hands-on, then please go ahead and do this step now. If you're just in listening mode, then please don't claim a username. We want to be sure that there are enough resources for the attendees who are doing the hands-on steps. So go to this URL here, bit.ly/pick-username. I'll leave this up so that you can see the URL as we go through the process of the next steps. So we'll split the screen a little bit here. So you can see the URL here, bit.ly/pick-username. When you go to that, you'll be taken to this spreadsheet here. There is a cluster URL. Don't go ahead and click that just yet. But what you can do here is in this username column, pick one of these that doesn't already have a user assigned to it. So one of these blank spaces, and enter your name, like so. I've chosen user 1, so please don't take that one, but any of these other usernames are available. When you view the spreadsheet, there's going to be a different URL here than in the recording, but go ahead and claim a username now. Once you've done that, note this cell here with the word OpenShift in it. That's going to be the password that you use when you log into this cluster. Your username is here, so my username is user1. Password for everybody will be OpenShift. So once you've done that and claimed a username, click this URL. That'll open the web console for OpenShift. You'll get a username and password field here. That's where you'll enter the credentials that you just chose. So user, whatever number, and then the password OpenShift. I took that wrong. OpenShift. Okay, so once you're logged in, you should see something like this. You should have a project named the same as your user. So if I'm user 1, I have a project named user 1. Go ahead and click on your project. I've deployed a web-based terminal for each of you. So if you go to networking here in the left navigation and then choose routes, then you can click on this URL to open this web-based terminal. And you can see here that it's opened in a separate tab for me. We'll pause here for a minute to give everybody a chance to get caught up, and I'll display the steps that we just talked about on the screen. So to get acquainted with this web terminal, we are going to start by installing the kubectl command line tool. Over in this pick username spreadsheet, you'll see a tab named copy paste. This contains all of the commands that we're going to be using throughout the lab so that you can copy and paste them instead of typing everything. So these will be available to you throughout the lab. If you fall behind, you can find them here. So the first thing that we will do is grab this OC login command, paste it in. If you're on Windows, you may have to do Control-Shift-V. Paste this in. It'll prompt you about an insecure connection. Go ahead and say yes. And then you have to enter your username and password. This will be the same username and password that you just used in the web console. So for me, it's user1. Everyone's password is OpenShift. Once you log in, you should see that you're on your project. And then what we'll do is we'll run this curl command here to pull down the kubectl file and install that. Okay, next we'll make it executable. And then add that to our path. Great. And now we can go back. We'll go back to our slides for a moment. So what we're going to do next is check that our environment is set up properly by running these two commands, which again are available in the pick username spreadsheet. So we'll run OC who am I. This will make sure that we're logged in. Okay, it should return your username. Then we'll run kubectl version. And that should return back some information. So if you've got that, then you're all set and we're ready to get started. Okay, so in this section, we're going to cover why we need Kubernetes, an overview of what it is and what it isn't, the Kubernetes API and kubectl, an overview of basic Kubernetes resources, what OpenShift is and how it relates to Kubernetes, and then we'll look at the OC command line tool to understand what it is and how it's different from kubectl. So why do we need Kubernetes in the first place? Well, containerized development of applications has become more and more popular and commonplace, and containers are a good way to bundle up and run applications. If you're deploying just one or two containers, then it's not too difficult. But if you're in production or if you're running many containers at scale, it's not that easy or efficient to try to manage all of that yourself. So think about things like downtime, failure, and recovery if a container goes down, scaling, etc. That's where Kubernetes comes in to take care of a lot of that for you. So what is it? Kubernetes is an open source platform for managing containerized workloads at scale. And as a container orchestration system, it can help you automate application deployment, scaling, and management. So in other words, you can cluster together groups of machines or hosts running containers, and Kubernetes will help you easily and efficiently manage those clusters. A Kubernetes cluster ends up running different Kubernetes objects, things like pods, services, deployments, and so on. Kubernetes objects are persistent entities that represent the state of your cluster, and you can manage them using the Kubernetes API. Here's a list of some of the most common objects that Kubernetes implements, and you work with each of these using the Kubernetes API. So Kubernetes uses these objects to represent the state of your cluster. They work as a record of intent. So once you create an object, Kubernetes is going to constantly work to ensure that that object exists. By creating an object, you're effectively telling Kubernetes what you want your cluster's workload to look like, and this is the cluster's desired state. Kubernetes provides a REST-based API, and the API object primitives typically include at least these 5 fields that you see here. Kind represents the kind or type of resource, like a pod, a service, a deployment. Metadata can contain things like the name of the resource and labels. Spec represents your desired state, and then the cluster is going to return back the status. So you can interact with a cluster via the API directly, or using a command line tool like kubectl, which is effectively a wrapper for the API. Let's start talking about some of these Kubernetes resource types, and we'll start with nodes first. So Kubernetes is designed to exist on multiple machines. It's a distributed system. So this allows for high availability and ease of scaling. A node is a host machine where containerized processes run, and node activity is managed by one or more master nodes. Next, let's take a look at pods. A pod is a group of one or more co-located containers. Most of the time, you'll have one container per pod, but there are cases where you may have more than one container per pod. Pods are the minimum unit of scale in Kubernetes, and pods get scheduled to run on nodes. Over here, you can see a sample pod spec. You can see some of those fields that we talked about, kind, metadata, etc. And in the container spec here, you can see the image that we want to run and the name that we want to use for it. So let's try this out. Over in our web terminal, we'll run these commands. And again, you can grab them from the spreadsheet, which we'll do here. So kubectl create -f because we're passing in a file, and then the pod that we want to create is this pod.json, which is the same pod spec we saw here. However, instead of in YAML format, which we saw in the slide, we have it in JSON format when we're passing it in. You can use either YAML or JSON with Kubernetes. It can understand both. So let's press enter here. Okay, so the message we get back says that our pod was created. We can run kubectl get pods, and that should give us a listing of the pods that are running. Okay, great. And then we can also run kubectl describe and pass in that pod's name to get more information about that pod. Lots more information in this case. Now I'm going to grab the IP address that's listed here. Let's find it. The IP address for our pod is here. Let's see what happens when I curl that. Port 8080. I get a message back. So this brings up an interesting point here. What if something happened to this pod and you had to bring up a new one with a different IP address? Or what if you needed multiple instances of this pod? This doesn't really seem like the safest or most effective way to access something running in a pod. And that's what services can help out with. A service acts as a single endpoint for a collection of replicated pods. So you can think of it as a load balancer. The service resource uses label selectors to discover where traffic should be directed. And note that services exist independently from pods. They have disjoint life cycles. Let's look at the service YAML over here. Note the selector of run hello K8s in the spec. That's going to be important for later. And let's try it out. I'm going to run kubectl expose, give it the name of our pod, tell it port 8080, and it says that our service was exposed. Now, let's get that service and return it the YAML for it. So you can see the YAML here for our service. From within our cluster, we can use something called kubedns to access this service by its name. So in my case, I'm going to curl hello-k8s.user1, :8080, you'll need to replace this X here with what your user name's number is. And I get the same message back. So instead of using, the IP address for our pod, we can use the service name followed by the name of our namespace or project to access that now. Now let's clean up before we move on. We're going to see a list of pods here running with this label of run hello K8s, and then we will delete those pods. And we'll also delete our service. Takes a moment for this to return, because when we issue that delete command, it's marking the pod for deletion, but it takes a little bit of time before all of that is completed and the command returns to us. Oops. All right, and then we'll delete the service. Okay. Normally you wouldn't spin up a pod manually like that though. To really take advantage of some of the benefits of Kubernetes like scaling and auto recovery or self-healing, you need an object like deployments. Deployments help you specify container runtime in terms of pods. So see that our deployment spec here contains the number of replicas, and it has an embedded template with the container spec. In this case, we're saying a replica is 1, which means we only want one pod. So let's create that deployment. Once again, we'll copy it from the spreadsheet. So we use kubectl create again, but this time we're passing in a deployment instead of a pod as we did the first time. So we've created this deployment, and we will expose the deployment, similar to how we did with a pod, but in this case we're exposing it with passing in the name of the deployment. Now let's take a look at everything that's running. We're going to run kubectl, get pod, service, and deploy. You'll notice I've abbreviated some of these identifiers. You can type SVC for service or type out the word service. Same with deploy and deployment. Okay, so what we get back is here's our hello K8s pod, our service, and our deployment. As before, we should be able to curl this using the service name from within the cluster. That still works. And now we had 1 replica. Let's scale it up to 3. And to do that, we can use this kubectl scale command. Let's try that again. And to do that, we can use this kubectl scale command, where we type kubectl scale, pass in the name of the deployment, and set replicas equal to 3. Now when we run kubectl get pods, we see 3 of these hello K8s pods. One of them is still coming up, but we have 3 of them now, where we had just 1 before. Okay, so to demonstrate the auto recovery capabilities, let's kill one of these pods and see what happens. So first, we ran kubectl get pods to see what's running. Grab the name of one of those pods. I'm going to copy this first one. And then we'll do kubectl delete pod and paste in that pod name. As it's deleted. And note here, this is our pods had FXCQ5, that's the one we deleted. We have one that starts with a Q here and one that starts with a Z. So now let's do kubectl get pods again and see what happened when we deleted that 1 pod. Oh, we have that one is terminating, and we have 3 still running in its place. And this one here, ZJPPS, that's new. So that pod was created as soon as the other one was marked for deletion, and that's how Kubernetes handles that auto recovery. We've specified in our deployment that we always want to have 3 of these pods running. So anytime the actual state does not match that desired state, Kubernetes is going to work to resolve that. Okay, so now that you have some of those Kubernetes basics, let's talk about OpenShift. What is it? Well, OpenShift is a distribution of Kubernetes, an enterprise distribution of Kubernetes. And in the case of this workshop, one of the sets of features it provides above and beyond Kubernetes is the development workflows, a developer-friendly web console, CLI tools, and so on. Here you can see some of the components that make up the OpenShift container platform. Kubernetes is at the core, and on top of that, there are some cluster services that allow you to do things like have over-the-air updates, additional monitoring, internal image registry, networking, routing, operator lifecycle manager, and Helm. On top of that, we have several different groups of services. Platform services, which allow you to manage workloads, give you additional functionality like service mesh support, serverless builds, CI/CD pipelines, logging. Application services help support your ability to build cloud-native applications by providing things like databases, runtimes, integration, business automation, and many other applications and services from our partners. And last but not least, we have our developer services, which enable developer productivity. These are primarily the types of things that we'll be focusing on in this workshop. So there is the ODO developer CLI, VS Code extensions, other IDE plugins, and then out of scope for this workshop, but also very useful, we have Code-Ready Workspaces, which is a cloud-native IDE, and Code-Ready Containers, which allows you to run a local copy of OpenShift on your own machine. So we've been primarily using kubectl up until this point, but you also have OC available to you in your web terminal. OC is an OpenShift command line tool that can be used as a drop-in replacement for kubectl. It does everything kubectl does, but it also provides additional capabilities for OpenShift-specific features like OC new app, login, projects, and so on. And you can try it. So you can try running OC get pods. And you can see that returns back the same information that you got when you used to run kubectl get pods before. Now let's try OC new app. We'll use this to deploy a simple Node.js front-end application. I'll open this GitHub URL so that you can see what it is that we are going to deploy. Do that over here. Okay, so this is a concession kiosk front-end application. All the code exists over here in this repository. Note there's no Docker file or anything, it's just a web app. So let's try OC new app. I'm going to copy this whole thing here, and we'll paste it. Oops. Didn't get that in my clipboard. Let's try that again. So let's run this OC new app command. I'll copy it here, let's paste it in. The syntax that we're using is OC new app, passing in that Git repository, and then giving it a name. We want to call this OC frontend. So I'll press enter. We're going to get some messages back. So it tells us it's determined that this is a Node app, knows that it's inferring that because we have a package.json file in the repository. And then this is using a project called S2I, or source to image, to create our runnable application image by combining the source code and a builder image. We got some messages back here. One, that we can watch the application logs as the build is running. So we can do that now if we wanted to. But first, let's go ahead and do OC expose service/OC frontend so that we can create a route for our application. A route effectively makes that service available and accessible outside of our cluster so that we get a publicly accessible IP address. Now we can also run oc get routes. Get that URL, this is the one we want here. So we'll copy it. And try opening that up in our browser if it's finished building. It has not finished building. So let's go ahead and look at these logs first so we can see where we are. Oh, looks like it just finished. It's just a moment too soon. All right, so here's our concession kiosk menu. This is our front-end web app that we've just deployed. Now let's go ahead and clean up by deleting our pod, service, and deployment. Everything with the label of run hello K8s. We'll wait for that to return. Okay, there we go. All right, now we're moving on from kubectl and OC to the OpenShift Web Console. In this section, we're going to learn how to access the OpenShift Web Console and explore both the administrator and developer perspectives. We'll look at the different ways to deploy applications and consume services, and we'll use the topology view to help you visualize and interact with the applications that we've deployed on the cluster. This section will be okay, let's switch back to our web console. If you don't still have the web console open, you can grab the URL from the Cluster 1 tab here in the spreadsheet. Make sure you've signed in with your username and password. All right, so let's take a little tour of the web console. So typically when you log in, you'll be in this administrator view. You can see the navigation here for the different sections that you can look at: operators, workloads, networking, storage, builds, user management, and administration. We could toggle here to the developer perspective. This is where we'll spend most of our time for the rest of this section. The developer perspective contains the topology view, which you see here. This is going to show you the different applications and services that are deployed in your project. The navigation on the left is a little bit different in developer perspective. There's a plus add menu, which we'll look at in a moment, which allows you to add applications or components or services to your project, monitoring, and search. And then we have segments for build, helm, more information about your project. And then this section of the navigation is actually configurable. So you can add items here that are frequently used. So we're going to use the plus add menu now to deploy. We'll use the plus add menu now to deploy an application in a couple of different ways. Let's start by deploying something from image. Click on plus add here. And then you can see there are several options. To start, let's choose container image. Here you have a choice of giving an image name from an external registry or using an image stream tag. Let's grab from our spreadsheet this image here. I have this on Docker Hub, so it's jkleinert/concession-kiosk-frontend:\latest. This is the same, different version of the same concession kiosk application that we deployed using OC new app before. So go here, you enter that in. You can accept the defaults here, except let's add -image at the end of this name so that we know that this is the one we deployed from an image. You have an option of choosing whether you want to deploy this with a standard Kubernetes deployment or a deployment config. Just leave the settings as is for now. And one nice feature that we get with the web console is instead of having to expose our service to get a route, when we do this from the web console, we get a route by default. So click Create. Okay, and we can see that here. Now this time we have this gray circle surrounding our deployment. This is an application grouping. It's just a conceptual grouping of components in an application, and it's done using standard Kubernetes labels. So we click onto this. If you want, you can look at the pod logs, and you can see that there's a service and a route included. This icon here is a shortcut to open that route. So if we click on it, we can see that our menu came up. Okay, so we've seen how we can deploy things from an existing container image. Next, let's look at how you would deploy from a Git repository, similar to what we did with OC new app before. Here in the plus add menu, you can see we have this from Git option. So let's click that. And in this case, we're going to paste in the URL of that Git repository. So I'll copy this. You can also find it in the spreadsheet here and paste it into the Git repo URL field. It's going to do some validation and try to detect which builder image to use, similar to what OC new app did. Behind the scenes, this is also using the source to image tool, just like OC new app. Again, we can choose which application grouping we want this to go into. We can use the same one we just used, and we'll call this concession kiosk frontend-git to distinguish it from the one we just launched. Again, here we can leave this with deployment, and we'll accept that route. So click Create, and you can see it coming up here. Now in this case, you can see the build running. If we want to click on that, you can watch the build logs. So you can see the progress as this is being built. But for now, let's click here to go to topology view. This circle here is light blue until our build is complete, the deployment is complete, and the pod is up and running. You can also move these items around if you'd like. And you can toggle here between list mode and topology view. So we'll let the build continue. Let's watch it as it completes. Almost done. Okay, so we see that push successful. Back over in topology view, you can see the green check mark indicates that. And now, if we take a look, this container is being created, and there we go. So now with it up and running, once again, we can click this, and there's our application. Next, I'm going to walk you through the process of how we can rebuild and redeploy an application using Git webhooks. I'm going to demo this, but if you do want to try to follow along, you would need to go ahead and fork my Git repository into your own GitHub account. Otherwise, you won't be able to add a webhook to it. So what I will do is click on this item here, this build config under builds, and scroll down the page. You can see next to GitHub, there is a link to copy the URL of the secret. This is our webhook link specifically for GitHub. If you were using some other type of Git repository, you may want to use the generic link instead. So I'll copy this, And then over in GitHub, in my repository, I go to Settings, and then Webhooks. And then we'll add a webhook. I have to authenticate. And now I will paste in that GitHub webhook URL here as the payload URL. Change the content type to application/JSON. Don't need to enter anything in the secret field. Because of the way the certificates are set up on our demo cluster, I do need to disable SSL verification. If you're doing this in production, you'd want to have properly configured certificates and leave that SSL verification enabled. And then from there, we'll click Add. So now we have our webhook set up, and let's go into the code and make a minor change to the H1 tag. I'm going to do that directly in GitHub for now. Though normally you would do this in your code editor and then git commit and git push. Just for the sake of time, let's do it here now. So we'll go into this index.ejs file. We'll directly edit it. And here where you can see the H1 tag says my concession kiosk, let's delete that and just call it concession kiosk-menu. So we will commit that. And what we should see, if you switch back to the console here and go into builds, this one here, this concession kiosk frontend -git-2, just kicked off a few seconds ago, and that was triggered by that webhook firing when we made the commit to the Git repository. So we can watch that build logs, similar to how we were doing before. And you can see here the commit date and time is right now when I am recording this for you. And in topology view, you can see that that build is happening because we have the little icon again. So again, if this is something that you want to try for yourself, it needs to be done in a Git repository that you own or have write access to. So you can clone my Git repository, or you can use one of your own and then deploy it, add webhooks, and see what happens when you make a change. Okay, looks like our build is complete and that redeployment is happening. If I click this now, what we should see is, there it is. The new title is just concession kiosk menu, where the my that we had before is no longer there. Okay, at this point, we are going to take a 5-minute break. Bring a timer over here for us. I'm going to take this 5-minute break now. And when it's done, we'll come back and we will move on to the next section. All right, we have just under 30 seconds left in our break. So we'll get started again real soon. All right, welcome back. I'll turn this off. And let's switch back over to our presentation. Our next section is going to be on iterative development with the ODO command line tool. So ODO is a command line tool built specifically for developers to help with inner loop development and to abstract away some of the Kubernetes and OpenShift specific concepts that some developers may not be interested in learning. We'll go through the process of deploying an application that's made of multiple components. You'll learn how to use interactive mode and link components within an application. And then finally, we'll use ODO Watch to do some iterative development. So we'll be working from our web terminal for the next few steps here. Let's start with the backend for the application. So make sure that you are in the /workspace directory. And then we'll clone the backend repo for this application. You can copy and paste it from the spreadsheet here. So this will be concession kiosk backend. And then cd into that newly created directory. Now, this is a Node.js application, and we will use ODO create to. So this is a Node.js application for our backend, and we'll use ODO create to create this component of our application. You can grab the command here. It's ODO create. We tell it what type of component we want, Node.js, give it a name, backend, and then we can name which application grouping we want to use by passing in the --app flag, and we'll call that concessions. So press enter here, and we get some feedback that it's validated the component. The way that ODO works, first we create a local component configuration, and then later when we're ready, we use ODO push to actually get that built and deployed on our cluster. So until you do ODO push, you're working locally. And we can see that component configuration by typing ODO config view, and that'll show us what it has been creating for us. Now we know that we want a URL for this backend. So we can use the ODO URL create command here, pass in the name, the URL, and the port that we want to use, which is 8080. That'll create a backend URL, that'll create a URL for our backend component. And now we're ready to do ODO push. We'll get some output here showing the steps that it's taking. And if you'd like, you can go to topology view and you can see this new application grouping concessions, and you can see the component here that is being created for us. But as I mentioned before, you'll keep the output will be available here as well, so you don't have to even look at the web console if you want to work completely from the command line. Okay, so that looks complete. Now we can run ODO URL list to get that URL that was created. We'll grab it here, copy, and paste. Now this is our backend for our application, so there's nothing at the root URL. So what we need to do is type /debug on the end, and we should get some kind of debug message back, which is great. So that deployed properly. All right, so now let's implement the front end. So let's go back to that workspace directory, cd/workspace. And I can see if you have a concession kiosk front end directory already. If so, you can run this command here, or even if you don't, just to be safe, rm-rf concession kiosk front end. Okay, now we'll clone that front end, the one that we've been using as a demo application up until this point. And then cd into that concession kiosk front end directory now. The way that ODO works is it's context specific. So the directory that we're in is the component that we will be working with. So that's why we need to make sure that we're in this front end directory now that we're ready to deploy our front end. So this time, let's use interactive mode. It's especially helpful if you're not familiar with the ODO command syntax. It will guide you through the process. So this time, let's just type ODO create. We know this is a Node.js application, so use your down arrows to get to Node.js. Press enter. You can use either version 10 or 12 of Node, but let's go ahead and choose 12 for now. You have the options here of local, Git, or binary. We're doing local since we're working from our local source code. You also have the option to choose the location of the path component relative to your current directory, and ours is in our current directory, so just hit enter to accept the defaults. What do we wish to name our component? Let's call it front end, rather than this long generated name that it created for us. And then what application do we want it to be associated with? Let's use the same one we used for the backend, which was called concessions. Enter. Which project? We want to keep it with the project that we have. We can select all the rest of the defaults here. All right, and then we got our message back that it's validating that component. So as we did with the backend, we'll type ODO URL create. And now we can run ODO push. And we'll wait for that to complete. You can see that it did get added to that same application grouping. It should be finishing up soon. There we go. So now we could either do ODO URL list or simply go over here and click on the route icon. Let me move this over. All right. So let's see what happens now that we have a front end and a back end. Let's see what happens if we try to place an order here. So I'll just enter something, place order, and what will happen is that we get an error. And the reason for that is that we haven't actually connected our front end and back end yet. So let's do that step now. So to do that, we're going to use ODO link. So all you need to do is type ODO link backend, because we want to link this front end component to our backend using port 8080. When you do that, you'll get some information back to you. And you'll see that the environment variables that are being used to share that host and port information are component underscore backend underscore host and component underscore backend underscore port. Now, because I knew that syntax ahead of time, our application is set up to expect that. And that's why when we make sure that that has finished deploying, we do ODO log -f. Double check that everything's back up. Now, if we open this URL and place an order, good, we should get a response. Now, we don't have our database set up. That's outside of the scope of this particular tutorial, But if we had a database deployed and also linked that as well, then we'd be getting back an actual order number and the details of the order. But we do have the front and back end components linked together now. So the next thing that we want to look at, we'll move this back to where we were. The next thing we want to look at with ODO is doing that iterative development that we talked about. We'll type clear so we can see a little bit better. Sometimes I want to test changes before I even do a git commit or git push. And ODO is really great for doing that inner loop development. So what we're going to do is type ODO watch in one window. And then I'm going to copy this URL here. You can follow along and do the same. So copy the URL in your browser and paste that in a new tab so that you have two terminal windows open. Type pwd over here to make sure where you are. What you'll need to do is cd into concession kiosk end. Okay. From there, and type ls, we're going to cd into the views directory. And you can see there's three files here. Index.ejs is the one we want to make some changes to. That's also the one we changed when we did the updates with the GitHub webhooks. So let's open this up. I'm going to use vi here, index.ejs. And what we'll do is we'll come down to this h1 tag, and I will, let's call this ODO concession kiosk. Now I'm going to do escape : WQ to save this. And then I'll quickly come over here to our tab where we had ODO watch running, and you can see that it picked up those changes and started a new build and deployment. So let's see if that worked. So we over here, we click the URL for our front end, and there it is. So without us having to, kick off anything other than that ODO watch before we started making changes, our changes were quickly pushed up and deployed to the application. So our changes were quickly pushed up and deployed for the application. So that brings us to the end of our section on ODO. There is a lot more you can learn, and there's also a brand new version of ODO that should be. So that brings us to the end of our section on ODO. There will be a brand new version of ODO that will be released in between the time that I recorded this for you and when the conference workshop takes place. So in the future, if you'd like to check out the brand new version of ODO, version 2, definitely come over to the GitHub repository here. OpenShift/ODO. And from there, you can go to the releases and you'll be able to find the 2.0.0 release of ODO and check that out. It has some new features and additional support. I recommend you check it out. All right, as we're nearing the end of our workshop today, let's do a little bit of wrap up and look at resources and next steps if you want to continue learning. So what have we covered so far? We started with an introduction to Kubernetes and OpenShift, where we looked at some of the most commonly used Kubernetes resource types. And we also talked about how Kubernetes and OpenShift are different and what are some of the features that OpenShift adds on top of Kubernetes. Next, we looked at how you can use the OpenShift Web Console's developer perspective, and we looked at different ways you can deploy and build applications using the Web Console. In the third section, we explored ODO, which is a command line tool, especially for developers, that helps with the iterative development and inner loop. And so now let's continue on to look at some resources and next steps if you want to continue learning. Got several resources here. Let me walk you through each of them. Kubernetes.io is the official Kubernetes documentation site. And in addition to documentation, you can also find tutorials and walkthroughs, lots of great information. KubernetesByExample.com is a resource that has example-based learning about different types of Kubernetes objects. You can follow along with these using something like Minikube, or you can use the OpenShift playground from learn.openshift.com as well. The next item here is the Kubernetes page on developers.redhat.com. This is a great resource to learn all about Kubernetes and cloud-native development, anything from articles to tutorials to videos and more. Learn.openshift.com is a link to our interactive learning environment where you can find hands-on interactive tutorials that you can do in a self-paced manner, as well as a link to the OpenShift playgrounds, which give you access to an OpenShift cluster that you can do whatever you like with for an hour, and then it will go away. So that's a great place to learn, explore, and experiment. Below that, we have the OpenShift page on developers.redhat.com, which has a lot of great resources specifically for developers who are using or want to learn how to use OpenShift. Below that, if you're ready to install a cluster of your own, either on the cloud, on premises, or on your local laptop, you can go to openshift.com/try and learn more about all the different options you have to install an OpenShift cluster of your own. And then finally, we have docs.openshift.com, which is the landing page for the official OpenShift documentation. So these are all great resources if you want to learn more. And with that, thank you. We do have some time left in the workshop, so we will remain here as long as anyone has questions. And you can use the remainder of the time for your own experimentation. If you have your own applications you want to try deploying on the cluster, you can do that, and we're happy to help you along the way with any questions you have. Thanks so much.